So good evening everybody, and it's 10:30 p.m. right now. So what we will be doing today is a Pramp session. For all of those who don't know what Pramp is, Pramp is kind of a mock interview that you can give, and there will be one random person who will be joining us, and once I will be an interviewer and the next time I will have to answer, he will be the interviewer, so you will get chances of answering. So yeah, it's 10:30 and we should join interviewer now. Video permissions needed. Sure. So it's telling me to wait for 2 minutes. The average wait time is 57 seconds according to them, but असलियत में it's much more than 57 seconds. Let's see who we will meet today. Okay, we have met someone. Hi.
Hello, hi.
Hi.
So I think it's your time to answer the question, right?
Yeah, right.
Yeah, so you can first read the question, and if you want any help, understanding the question, you can ask.
Sure.
Does that sound right? Okay.
Yeah,
So,
sounds good.
yeah.
So, K missed array sort. Okay, given an array of integers ARR, where each element is at most k places away from its sorted position. Code an efficient function sort k missed array that sorts the array. Okay, for instance, for an input array of size 10 and k2, an index belonging to index 6 in the sorted array will be located at either index. Okay. Analyze the time and space complexities of a solution. How is this example? K is equals to 2. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so according to me, what I understood from the question is that we are given an array of integers,
Yes.
right? And for each element, its correct position will be from the current index minus k to the left or to the right. Like if
At most, yeah.
at most, yeah, at most in the worst case, right?
Yeah, in the words.
Yeah. Okay. So what I can do from this, what I'm assuming one of the solutions can be, I'll iterate through the array. Let's
Okay.
say I will iterate through the array, the first element. Now
Hmm.
what I will do is I will go till the first k elements.
Okay.
Okay, like for here example, k is equals to 2, so I will go from 0 till 0, 1, 2, right? So
Okay.
till the second index,
Yeah,
and I will
okay.
pick the minimum out of the three elements.
How will you pick that minimum?
Minimum, I will store I will take a variable. I will store the current element, and if the next element is minimum than that, then I will update the minimum.
Okay,
So
and then after that, this will you will do for the entire array, right?
yeah, yeah,
So, what is the time complexity of that? Yeah,
yeah.
yes.
If my k would be n,
It's a different number, and n is a different number. So, in
so
terms of n and k,
it will be
what will be the yes?
O of n into k.
N into k.
Yeah.
Okay, this is also a right approach, but can you think of like a little bit of optimize approach?
Okay. Yeah.
Yeah,
Yeah. So
yeah.
what I can do is either I can create a heap, min heap,
Okay, right.
and what I can do is I can enter the first k elements in the min heap,
Exactly. Yeah.
and
Yeah.
I will extract the minimum, and then I will put the minimum at that index, and I
Mhm.
will add the next element to the min heap.
Okay.
So in this manner I can go through the whole array,
Hmm.
and that will be in there'll be n log k.
Okay, yeah, that's correct. So, yes, so you can start implementing the code, and yeah, so you can start by writing this now. So,
Okay, okay.
One eternity later.
I have initialized this n. The answer integer would be our final answer.
hmm.
This priority queue is the min heap, and first of all, uh, I have written these two conditions just in case that if my k is given is greater than the size of array. If such is
Hmm.
the case, then we have to stop at n if n is smaller, so we have to take care of both the conditions.
Hmm.
After that, simply I have pushed the first k elements, then I will start from the k index and go till the last, adding in the answer array by removing from the min heap and then adding the current element in the min heap.
Okay,
So
now it is okay.
failed something,
But
and if
okay, hmm. But don't you think the size of the priority queue should be k plus 1?
k plus 1, okay, yeah,
Yeah,
yes, I think
because
this is the, yeah. So it should go up to k, and from here
uh,
it should go from k plus 1.
yes.
Yes. Yeah,
Yeah.
now it's correct. Yeah.
Size.
So shall we swap
Yeah,
roles?
yeah, sure.
Okay. Okay. So you may read the question first. If you find any difficulty, I'll clear the doubts. Okay. Fine. Cool.
Let me just change the language first. All this is just to iterate to the entire array
Yeah.
and check if any element like that exists, right?
Yeah.
And we also need to return the lowest index. So that means we need to start from the starting position. Okay.
Yeah.
But and so that will take around a big of n time. Okay, but I guess we need to do in like less than that, right?
Yeah.
So now the arrays are sorted, so we can implement binary search.
Yeah. Absolutely.
Okay, and we need to return the lowest index I, for which array of I is equal to I. So we can just do okay, but we don't know from where it no. Okay. Then we will go to the left and right. But how will we determine do we need to go to the left or right?
Yeah. If you are thinking about binary search, so there should be a solid condition on which you can say that your answer lies to the right of it or
Hmm.
to the left, right?
Yeah.
Yeah. So if it isn't clicking you, let's go through an example. Maybe it can help you. Like
Hmm.
if we go through this example particularly,
Hmm.
so our mid will be, you can try
Uh,
binary approach. Yeah.
like in this case the mid will be like 0 plus 4 by 2, so it will be 2, so it will be 2 here. But yeah, so in this case we did find our index.
Yeah.
But let's take the second example, that is minus 1036,
Yeah,
right?
sure. Hmm.
Uh, yeah, so in this like this 3, so 3 is not equal to 2.
Hmm.
Okay, so
Hmm.
mid. So, but in this case, how can we decide that should we go to the left or to the right?
Right, let me help you. Yeah, yeah, let me just tell you how we can do this. Like if you get some value at middle index, if the value is greater than the index,
Hmm.
then even if we get consecutive numbers, the
Hmm.
solution will never be in the right. Right, if let's suppose the value at 2 index
Hmm.
is 3. Okay.
Yeah, in this case, yeah.
So even if you take consecutive elements after this, like after 2 you take 3, it will be at index 4, right?
Yeah, after that, yeah, it will be at index 4, right? So we need to go to the left, yeah, in this case. So I think that if the value at the index, that is our mid index, is greater than the mid, in this case, we will go to the left side because all the
Value.
values after that will be greater than that, right?
Yeah.
Yeah. So that will be our condition, right? So I'm starting to write the code now.
A few moments later.
Yeah, just wait a minute, just wait a minute. Think about this, like if you get some value that is at the mid, that is equals to mid, do we have to return that mid, or you need to search on the left too, that if there can be more than one solutions, right?
Yeah,
But you
we need
need to
to
return the leftmost mid.
yeah, the lowest
Yeah,
yeah, the lowest height.
so instead of returning mid, what you can do is you can set your rightmost bound till here,
Mm.
so that the answer either can be on the left or this will be the answer.
Okay. So low equal
So
to
you can
sorry,
store this
high
mid
equal to
somewhere.
mid.
Yeah,
Yeah. And, something like this.
yep.
But okay.
Mid -1 or mid.
Minus one. Okay.
Yeah. Now it's look okay to me.
So when will we return this? Okay. Do we need to check here?
Yeah. At the last, you need to check if your answer lies in 0, 2 and -1.
Okay. Pass 3, fail 3. Sure. Expected is 0, and we got -1. Okay. We need to do low equal to high. Oh,
Yeah.
okay. It's size, so that's why low equal
Yeah,
to
if
high.
whenever we use this mid +1 and mid -1, we generally do this. I mean, we keep an equals to.
Yeah, these two things are like quite confusing
Yeah,
in
binary
binary.
search is actually confusing. You need to
Yeah,
think of the boundary condition.
yeah, exactly.
Yeah.
That's a
Yes.
good question, like in this.
Yeah. So, any reviews on what things I can make better? Yeah. Any?
I don't think only the improvement, like just keep practicing in DS algo, and yeah, that's all. Okay.
Okay.
Yeah.
Thank you.
Yeah. Bye.
Bye.